Hi, everybody. Today I'm going to be going over the worksheet we did in recitation this week. If you want to find a specific problem, I've given you time points for everything. So let's start with the first question where we're just looking at how many sig figs are in each of these numbers. So we are never going to include our times 10 to the whatever powers. They are not part of the number, they're just giving you magnitude. But we will count these first four numbers because we will always count our non-zero numbers, and then zeros that are sandwiched in between non-zero numbers are also always significant. So in this case, we have four numbers, and they're all significant. So four sig figs. This next question, we have 0.056. Whenever we have zeros leading a number like this, we call these leading zeros, and leading zeros never are significant. So we're not going to count these two leading zeros. We're only going to count our two non-zero numbers. So this number has two sig figs. For C, again, we have leading zeros. We're not going to count those. But trailing zeros, that is to say that zeros at the end of a number, we count those because those were measured. If the scientists did not measure this zero, they just would have left it off. They don't just add zeros for no reason. So the zero is significant at the end of a number. So there are three sig figs in this question. Moving on to D, this one is a bit tricky. So whenever you have zeros at the end of a number for a number that is larger, it doesn't have any decimal places, the zeros are significant if we add a little decimal point at the end of the number. That's to indicate that they did measure out all the way to the ones place. So in this case, all four of these numbers, the 2, the 6, and the 0 and the 0 are all significant. So this has four sig figs. Piggybacking off of that, E is a similar situation where we have trailing zeros and a number that doesn't have decimal places. So is the one place zero significant or not? Ultimately, we don't know. So we cannot actually define the number of sig figs in this number. It is ambiguous. It could have two or three sig figs. We don't know. And it's important to note that none is not a correct answer here because this number does have sig figs. We're just unaware if it is two sig figs or three. And then finally, we have a number with trailing zeros behind the decimal place. The zero is significant, so this has two sig figs. So next up, we're going to be doing some multiplication and division problems. When determining the number of sig figs in a multiplication and division problem, you are going to round your answer to have the number of sig figs that matches the number of the least number of sig figs. So let's go ahead and count how many sig figs we have in both of our numbers here. On the left, we have a number that's made up of all non-zero numbers, so all three digits are significant. So there's three sig figs here. Other one is a number that has leading zeros, which we won't count, and then two non-zero numbers. So there's two sig figs. So our answer has to have two sig figs. So let's go ahead and use our calculator. So 32.3 times 0.0015. And we find this is our answer, but we need to make it to where it has two sig figs. So these zeros are not going to count, but then one sig fig and two sig figs. So we're going to cut it off at 0.048. And now we need to make sure that we are rounding correctly. Remember, if it's if the number preceding where you round is below 5, we round down. If it's 5 or higher, we round up. In this case, our number is a 4, so we're going to round our answer down to 0.048. 0.048 to sig figs. Let's do the same thing for our next problem. So here we have a number with three non-zero numbers and then a trailing zero, which is significant. So our first number has four sig figs. And then for our next one, we have leading zeros. Those don't count. And then 1, 2, 3, 4, 5 numbers that are non-zero. So this one has five sig figs. So our answer should have four sig figs. Let's do the math. And we find that this is our answer. So we need four sig figs, 1, 2, 3, 4. So we're going to round at the ones place. And then the number here is greater than 5. So that means we are going to round up our number. And our answer is 9,047 with four sig figs. Let's move on to our addition and subtraction questions. This is where a lot of people got tripped up. So Remember, for addition and subtraction, we determine our sig figs at the end of the problem, and we round to the number that has the least number of decimal places. So let's look at our numbers here. We have 9.50, that goes out to the hundredths place, and then minus 8.325, which goes out to the thousandths place. So we have to round our answer to the hundredths place. So let's do that. Let's do our math. Minus 8.325. And so we find our answer is 1.175. We are rounding to our hundredths place. So we are going to round to here. And our number is a 5, so we have to round up. So our answer is 1.18. And now we can figure out how many sig figs our answer has. Our answer has a total of 3 sig figs. Let's move on to our next one, where we're now going to do the same problem, except we're going to add. So the same thing again, we have to the hundredths place here, to the thousandths place here. So we're going to round our answer to the hundredths place. So 9.5 plus 8.325. And so we have to round to the hundredths place. Again, at 5 here, so we have to round up. So our answer is 17.83. And our answer has 4 sig figs. So remember, addition and subtraction, you can end up with more sig figs than your smallest, your number that has the smallest number of sig figs. Because our smallest number of sig figs here is 3, but our answer should be expressed with 4. It's because we have decided that with addition and subtraction, that is how we determine our sig figs. We determine at the end. So let's move on to some mixed operations. So we will start with our parentheses here, and this is addition and subtraction. So let's look at how many decimal places we have here. Both of these have 6 decimal places, so we won't have to do any rounding in our answer, thankfully. So let's do the math. 0.000345 minus 0.000067, and we find our answer is 0.000278. And we don't have to do any rounding because both of our numbers that we start with had 6 decimal places, and our answer has 6 decimal places. But now we need to count how many sig figs we have here. Our leading zeros do not count, so we have 1, 2, 3 sig figs. So now we're going to do a multiplication division. And so this has 3 sig figs, and our other number, 10.24, has 4 sig figs. So our answer should have 3 sig figs as a result. So we're going to divide by 10.24, and we find this to be our answer. And we want to have 3 sig figs, so we're not going to count our leading zeros. 1, 2, 3. And then our number that gets cut off is a 4, so that means we round down. So our answer is just going to be 0.0000271, and that answer has 3 sig figs. So let's do this next one. So again, we're going to start in our parentheses. We have a number that goes to the tenths place and a number that goes to ones place. So we have to round our answer to the one place. So 45.0 plus 32 is 77. And it has already kindly given it to us to the ones place. So right now we have a 77 in here, and 77 has 2 sig figs. And then we're going to be doing a multiplication and division. So we have something that has 2 sig figs times something that has 3 sig figs. So ultimately our answer should have 2 sig figs, since we have to choose the one that has the least number of sig figs. So times 8.35, and we find our answer is 642.95. So this is going to be a bit weird because it feels weird that we're rounding off places that are in front of the decimals place, but we have to only have 2 sig figs. So 1 sig fig, 2 sig fig. So we cannot include anything to the right of the 4, and we're going to round up or down. In this case, since our number is getting rounded off as a 2, we round down. So we have to express this as 640. But if we write down 640, this is ambiguous as to whether it is 2 significant figures or 3 significant figures. So we have to write this in scientific notation. So we can write that as 6.4 times 10 to the second power. And finally, for this last question here, uh, This question, we have to determine what value we should report. So we can definitively tell that it's between 4.0 and 4.1. And so if you remember from my lecture, we always go one decimal place past where we're certain. So we're certain of the tenths place, but we are not completely certain of the hundredths place. So we need to take a guess. So you could do a couple answers here. Pretty much anything between 4.05 and 4.10 is all acceptable. So 4.05 works. 4.06 works, 4.07 works, 4.08 works, 4.09 works, and 4.10 works. What does not work is 4.1 because this is if someone gets this, they assume that you are certain of one's place, but you're uncertain on your tenths place. So you took a guess on your tenths place. To show that we are certain of our tenths place measurement, you have to include one decimal place further. So it had to be one of these answers. And then for the definition down here, it's just any number that is reliable and absolutely necessary to determine the value of a number. That's it. If you have any questions about anything from this worksheet, please feel free to stop in my office hour. I do office hours on Tuesdays from 3:30 to 5:30 in Physical Health Science Center, room 303, same building as we do our recitations. Feel free to come by or email me.